Today we are going to discuss about ring counter. Last class we are discussed about shift registers. One of the application of shift register is that they can be arranged to form several type of counters. Example of this type of shift register counter is ring counter. It is also called a basic ring counter or the simple ring counter. And another shift register counter example is twisted ring counter. Twisted ring counter is also known as Johnson counter. Is Johnson counter. So these are the application of the shift register. It can be act as a ring counter, and there are two types of ring shift register counters. One is ring counter and second one is Johnson counter, and it is also known as twisted ring counter, twisted ring counter, or switch tail ring counter. Switch tail ring counter. Then what is a ring counter? Ring counter is the simplest shift register counter. So here a ring counter is a circular shift register with only one flip-flop being set at any particular time. So at any particular time only one flip-flop being set and all others are cleared. A single bit is shifted from one flip-flop to next to produce the sequence timing signal. So if there are three flip-flops are there, then only one flip-flop is set at a time. Then on the next clock pulse it will set the next flip-flop. So it's look like a single bit is shifted from one flip-flop to next. So here ring counters are implemented using shift registers. In this diagram the basic ring counter using D flip-flops is shown here. This is a 4-bit ring counter. So using D flip-flop, here it is, D flip-flop is here. It uses 4 flip-flops, so it's a 4-bit ring counter and using D flip-flop. The D flip-flop has only a single input D and the output signal. And here initially the value, here it is the flip-flops are arranged as in a normal shift register, that is the output of each stage is connected to the D input of the next stage. The output of the second flip-flop is connected to the D input of the next stage, but the Q output of the last flip-flop, here it is connected back to the input of the first D input of the first flip-flop here. So such a that the array of flip-flop is arranged in a ring, so it is look like a ring. So therefore its name is ring counter. So it is essentially a circulating shift register connected so that the last flip-flop shift its value into the first flip-flop. There is usually only a single one is circulating in the register as long as clock pulses are applied. For example, here it starts from 1. Here first flip-flop is initially the flip-flop output will be Q0 will be 1 and Q2 will be 0, Q1 will be 0 and QD will be 0. On the next clock pulse it will be shifted. That means this 0 will be here 0, and this 1 will be shifted to here, this output. D input എന്ന് പറഞ്ഞാൽ എന്താണ്, whatever in the input, D input, that will be given to output. So data input, it's also known as data input, D input. And this previous 0 will be shifted, this 0 will be shifted to here, and this 0 will be shifted to here. So initially it is 1 0 0 0, then this last one is shifted to, on the next clock cycle it is shifted to here, this one will be shifted to right 1, then this 0 will be shifted to here, and next 0 will be shifted to here. So it is 0 1 1 0 1 0 0. On the next clock pulse, this again, this 0 will be shifted to here, this position, and this 0 will be shifted to here, this 1 will be shifted to next position, 0 will be shifted to here. So 0 0 1 0. On the fourth clock pulse, what will be happen? On the next fourth clock pulse, again this 0 will be shifted to here 0, then this 0 will be shifted to next position, this 0 will be shifted to next position, and this 1 will be shifted to this. Again on the fifth clock pulse, what will be happen? Then on the next clock pulse, this 1 will be shifted to here, then 0 will be shifted to next, and again 0 will be shifted to next, 0 will be shifted to next. So again the starting counter value will be reaches, that is 1 0 0 0. Then again this circuit will be repeated. So initial value of this register is 1 0 0. Here another example, and it is shown here is a shift register T0, T1, T2 and T3, and initial value will be, it is a shift right register, so initial value will be 1 0 0 0, and a single bit is shifted right with every clock pulse and circulated back from T3 to T0. And here also another figure shows this. This is each flip-flop, shows 1 bit storing and 1 bit is shifted to right, and the last output is connected to the D input, first D in flip-flops D input, and it taken output from each flip-flop QA, QB, QC and QD, and each flip-flop in a one stage once every clock pulse, and produces one of the 4 timing signal. So each output become a 1 after the negative edge transition of the clock pulse, and remains 1 during the next clock pulse. In this figure here, here it is shown a positive edge clock pulse, here it is negative. If we connected with here 0, then it is a negative clock pulse. So if here it is in this figure, it is inserted 0 here, so it indicates negative clock pulse. So the diagram shows a negative edge transition, there is a one is shifted from one location to another, and this is the state diagram. Its initial state is starting from 1 0 0 0, then it's 1 is shifted to right 0 1 0 0, then again 0 1 0, then 0 0 0 1, then again is 1 0 0 0. The same is represented using a sequence table using the output of the clock Q1, Q2, Q3 and Q4, and clock pulse is here. Then each time, initially 1 0 0 is the initial state, then each time each clock pulse one is shifted to the right. So this is the timing diagram. Initially, we know that the Q1 is initially 1. So during the negative clock pulse, here negative clock pulse, the Q1 is 1 and Q2 is 0 and Q3 also 0 and Q4 also 0. On the next clock pulse, negative clock pulse, the Q2 becomes 1 and Q1 goes to 0 and Q3 also and Q4 also 0. During the next clock pulse, this is 1, 2, this is 0, 1, 2. Then third clock pulse. During this clock pulse, Q3 becomes 1, Q2 remaining Q1 and Q2 remains 0 and Q3 become 1 and Q4 0. On the negative next clock pulse, Q1 0, Q2 0 and Q3 0 and Q4 becomes 1. And next negative clock pulse, Q1 becomes 1, Q2 becomes 0, Q3 becomes 0 and Q4 becomes 0. And this sequence will be continued. And we can generate this same sequence using a decoder and using a counter. So the decoder decode the first state of the counter and generate the required sequence of timing signal. So using a decoder and a counter, we can generate the same timing sequence. Here we are using a 2-bit counter and here we are using a 2-bit counter and using a 2 to 4 decoder for generating a 4-bit ring counter sequence, timing sequence signal. So ഒരു 4-bit timing sequence counter generate ചെയ്യണമെങ്കിൽ എന്ത് യൂസ് ചെയ്യണം? 2-bit counter യൂസ് ചെയ്യണം, അതുപോലെ 2 to 4 decoder യൂസ് ചെയ്യുക. സോ decoder ഔട്ട്പുട്ട് എന്ന് പറയുന്നത് T0, T1, T2 and T3. This is all about ring counter.